So here I have grabbed all the components, and the closest capacitor that I could find is 4.7 400 volts capacitor, which I salvaged from something else. And instead of using a fusible resistor, which I don't have at the moment, I'm using this really thin piece of wire right here. See this? It's really thin piece of wire, which I don't remember from which circuit. Maybe it's from the pulsing circuit, and it looks much similar to the pulsing circuit that I have shown you guys in the wobble head video, which if I remember I will attach it up here. So I'm using this really fine copper wire as a fusible resistor, and I will do the work outside the camera, and I'll be back once I have done that. But before that, let's use this series bulb tester to see if that actually is the case. So I'm just going to connect the tester. I'm just going to plug this in, and let's measure the output. This is center positive, so I'm going to attach this to the inner pin and this to the outside. And what? Oh, it's in continuity. Oops. See, that usually happens if you that's the reason why you have to always double check the position of switches. If, as always, Big Clive says, do not forget to change the position of your switch back to voltage, otherwise you're going to see fireworks. I'm using my wallet as a support. I hope this works. And this piece of wire, using this piece of wire, I'm going to short circuit this resistor right here, and you guys can see the voltage if there is any in the multimeter. And if I'm using the series bulb tester, because if I short circuit something else instead of this fusible resistor, only the bulb will glow, not my eyes. So let me just plug this tester in, and you can see it's on, and make sure the bulb bypass is off. Yes. And if I'm going to short circuit, and just watch this reading right here, okay? And also you can watch the LED also here. I'm going to short circuit this. I'm just keeping in mind that this is also a dangerous situation, but I'm just testing to see if this works. Okay, the bulb is showing, which indicates a short circuit, but now it's fine. Maybe that's the time the time you see the bulb glowing was the time that is needed for the capacitor to actually build up the charge, because that's going to create a short circuit kind of feel. That is the reason why the bulb actually turned on at the moment. But yeah, it solves the problem. If I short circuit it again, see, that is 12 volts at the output. See the meter, the bulb is now fully turned off and the LED is glowing. So that fixes the issue. So that is the reason why we need a series bulb tester, because without that, if we short circuit it, something bad would have happened. So now I know this thing works. I'm going to solder this piece of wire as a fuse, and this replacement capacitor. Hopefully this will blow just like the fuse did, because this is really fine wire. I'm hoping that it will burn. So I'm going to do that off camera, and I'll be back once I'm done. Okay, so guys, I think now I have fixed it. I have used a fuse wire, I have replaced with a capacitor, and surprisingly enough, underneath that resistor it says NTC right there. So they actually made an effort to actually make this board a good one, but they see there is an option for even bigger transformer right there, and so they actually made an effort to bring this board to a good level, but those silly isolation issues and everything, that is what brings this board down. So let's plug this in. Let me just move away the unwanted stuff, and let me just bring in the series bulb tester. And here, as you can see, I have attached the output of the leads to this multimeter. So let's see if it blows up. It blows up. This is the first time I'm turning it on, and that's it. The bulb is just gradually lit, and the output is at 12.2 volts. In fact, if I turn this, see, now that was really a good thing. See, the moment I turned the bulb bypass off, the fuse just instantly blown. Wow, that's the first time happening in my videos.